Hello everyone, welcome to this video. In this video, I want to look at the two theorems that concern parallel lines and perpendicular lines in coordinate geometry. So, what is a parallel line? What is a perpendicular line? What are parallel lines and what are perpendicular lines? So, two lines are considered to be parallel if the distance between any points along that line, along one line, is the same as the distance of any point from, let me say that again. It's very easy to mess these things up. So two lines are considered to be parallel if the distance between them is the same throughout any point along that line. So if they say on a line, they're like 20 points, and point 1 and point 1, the distance between those 2 points is 2. Then the distance between point 15 and point 15 on both lines should be 2. And the distance between point 20 and point 20 should be 2. So the distance between the two lines is like the same throughout. So they are never meeting, they are never slanting like towards each other or away from each other. The distance is maintained. Yeah, they just, the distance is just the same from the beginning of each line to the end of each line. So those are parallel lines. Then perpendicular lines are lines that meet at 90 degrees. So if you have one line that is vertical and then another line that's horizontal, the way we have like our X and Y planes, those two lines, if they're meeting, they are cutting each other, and the angle at which they're cutting each other is 90 degrees, then those two lines are perpendicular. So perpendicular lines are simply lines that are cutting each other at an angle of 90 degrees. Now, what do these theorems that we're concerned about today say? So the theorem concerning parallel lines tells us that if two lines that are not vertical or horizontal, and by that I mean that have a gradient, because if a line is vertical or horizontal, they don't have a gradient. The gradient is 0. So if a line is not vertical and it's not horizontal and has a gradient, say 2, then any line that's parallel to that line will have the same gradient. So if I have a line, as I was saying, that is slanted at an angle and has a gradient of 2, then any line that you can draw that is parallel to that line will have the same gradient. So any line that's parallel to that line will have a gradient of 2. That is a theorem. Then the theorem concerning perpendicular lines states that if you have two perpendicular lines, their gradient, so the gradient of one line and the gradient of the other line, which is perpendicular, if you multiply them, the answer is always -1. Now, what does this information help us, or how does it help us? So let's see. Okay, so let's look at some examples and see how we can use these theorems. I don't know if I'm saying the word correctly, but show that the lines that are going through points 2,5. So this is the first line. The line is going through point 2,5 and point 4, 25 is parallel to okay, a line going through points 4, 10, and the point 6, 35. So the question says, show that these two lines, a line that's going through point 2,5 and 4,25, and the line going through point 4,10 and 6,35 are parallel. So he said parallel lines should have the same gradients according to theorem. And to show that these two are parallel, we need to compute their gradients, and if their gradients are the same, then these two lines are parallel. So how do we do that? We know that gradient is equal to change in y over change in x. So y2 minus y1, y2 minus y1 over x2 minus x1. So the first point, this point to be my 1, and this point to be my 2. So using this for the first one, my y2 is 25, and my y1 is 5, my x2 is 4, x1 is 2. This gives me 25 minus 5 gives me 20. 4 minus 2 gives me 2. And 20 divided by 2 gives me 10. So the gradient of the first line is 10. Let's see the gradient of the second line. My y2 is 35, y1 is 5, y1 is 10 over 6 minus 4. So say 35 minus 10 is 25. Wait, I think this was supposed to be 15. Let me just change this to 15. So that we have the so we have 20 there. Then we have 2, and then we have 10. So these two lines are parallel because the gradient is the same. And we've shown this by computing the gradient for, sorry, by computing the gradient for each line. So that is one way we use the information in the theorem. Two lines are parallel, the gradient is the same. So we've shown that this line, which is going through these 2 points, 2,5, 4, and 4,25, and this other line are parallel because they have the same gradient. Now let's look at another scenario. Just make some space. Suppose we're given a question to say, find the equation of a line that is parallel to this line, the line that's given by 2, negative 2x plus 6. So parallel to this line and going through the point, let's call it point A, going through the point A, which is at 1, 10. So we're finding the equation of a line that's parallel to this line, y is equal to negative 2x plus 6, and goes through the point 1, 10. So to solve this question, you should realize that the equation of the line we are given is written in standard form. And because it's in standard form, we know that it's written in the form y is equal to mx plus c. And m is the gradient. So our gradient in this case is minus 2. So the gradient of this line is negative 2. And having found the gradient, and we're told that the line is parallel, the line that we're trying to find the equation for is parallel to this line, meaning it should have a gradient of 2 also. So now that we have the gradients, we have to find the equation. This is a case where you're given a gradient and a point, then you have to use a certain equation to find a standard equation. And that equation is y minus y1 is equal to m, which is the gradient, multiplied by x minus x1. So y1 and x1 are the coordinates from the point that's given. So we have y minus 10 is equal to, our gradient is negative 2. Then we have x minus 1. And then we solve and simplify and leave it in standard form. So negative 2 multiplied by x is just negative 2x. The negative 2 multiplied by negative 1, that's positive 2. So we have y minus 10 is equal to negative 2x, negative 2x plus 2, like that. And since we want it to be in standard form also, we move the 10 to the right hand side. So it expresses the equal sign and becomes positive on the other side. So we have y is equal to negative 2x plus 2 plus 10. 2 plus 10 is equal to 12. So y is equal to minus 2x plus 12. So this is the equation of the line. So that is how you find the equation of the line. Now let's see if we can look at a few examples on how to use the other theorem on perpendicular lines. So we're going to begin with another show that kind of question. So let's see. So show that the line going through the point 6, 0 and times 12, 0 is perpendicular to the line going through 8, 10, and the point 4, 8. So remember, when two lines are perpendicular, it means that when you have the gradient of one line and you multiply it with the gradient of the other line, the value or the answer you should get is -1. So the first thing is for us to prove or to show that these two lines going through these 2 points, 2 sets of points are perpendicular. We have to find their gradients. And once we find their gradients, we multiply them. And if they give us -1, then it is true that they're perpendicular. If the answer is not -1, then they're not perpendicular. So again, gradient is equal to change in y over change in x. So y2 minus y1 over x2 minus x1. So these are my ones, these are my twos. For the first line, my y2 is 0. Wait. Let me check my points again. So point 2 and the first one should be 0, 12 and not 12, 0. So 0, 12 like that. Okay, so y2 is 12. Y1 is 0 over x2 is 0, x1 is 6. This gives us 12 divided by -6. And this gives us -2. So this is the gradient of the first line. Gradient of the second line, y2 is 8, y1 is 10 over x2 is 4 minus 8, which is x1. 8 minus 2 is -2. 8 minus 10, sorry, is -2. 4 minus 8 is -4. When we divide that and simplify, we have negative divided by negative gives us a positive. 2 over 4 is simply 1 over 2 when you simplify. So the gradient of the second line is 1 over 2. Now the theorem says if we multiply the two gradients and the answer is -1, then these two lines are perpendicular. So let's see if they're perpendicular. So this is M1 and this is M2. So this is what the theorem says. M1 times M2 is equal to -1. So let's say our M1 is -2 and our M2 is 1/2. -2 multiplied by 1/2 is -1. And since it's -1, these two lines are perpendicular. So that is how we prove that two lines are perpendicular. If the product of their gradients is equal to -1. Let's look at another example. So we're asked to find the equation of a line that is perpendicular to this line, 2x plus 1, and it goes through the point 1, 3. So this line is perpendicular to the line y is equal to 2x plus 1, and it goes through the point 1, 3. So again, the equation of the given line is in standard form. So from that standard form, we're able to tell that the gradient of that line is simply 2, because it's written in the form y is equal to mx plus c, where m is the gradient. So m in this case, the coefficient of x is 2. And since we're told that the line that we're trying to find the equation for is perpendicular to this line, and from our theorem, we know that m1, so let me just call this m1, m1 multiplied by m2 should give us -1. So using this, we can compute the gradient of that line that we're looking for. So our m1 is 2 multiplied by m2, which is equal to -1. When we solve for m, divide both sides by 2, we find that our gradient for that line is simply -1/2. And now since we have the gradient and we have a point, we can use the equation y minus y1 is equal to m multiplied by x minus x1 to find the equation of this line. We know what y1 is. Y1 is 3. We know what m is. M is -1/2. Then x, we know what x1 is, which is 1. And then we solve and simplify. -1/2 multiplied by x, that's simply -1/2x. -1/2 multiplied by -1, that's +1/2. So we have y minus 3 is equal to -1/2 x plus 1/2. And then since we want it in in standard form, we move the -3 to the right-hand side. And once we do that, since it's crossing the equal sign, it becomes positive on the other side. So we have y is equal to -1 over 2x plus 1 over 2 plus 3. 1 over 2 plus 3 is simply, let's see, should be 7 over 2 in my mathematics. So our line, our line is y is equal to -1 over 2 x. Let me just write it properly. So y equals -1 over 2 x plus 7 over 2, like that. So that is how we find the equation of the line given the information before. So basically that's it. The two theorems and some of the examples in which we can use the information from the two theorems to solve some questions and some problems. Thank you for watching. See you in the next video.